Hi everybody, let's look at another example. In this problem, you have $1,000 to invest in a bank that offers 4.2% annual interest on a savings account compounded monthly. What annual interest rate do you need to earn to have the same amount at the end of the year if the interest is compounded continuously? Alright, so when we read this, we see that there's two compoundings. One that's compounded monthly, and then another compounded continuously. And when we look at this again, we are trying to find the interest rate that's compounded continuously so that it's the same amount for the interest rate that's compounded monthly. So what we can do is we're going to use, when it's compounded monthly, we use the formula A equals P times 1 plus R over N to the N times T. And then when it's compounded continuously, we use A equals P E to the RT. So for this first bit of information, the P is 1,000 and R is 4.2%. When we change that to a decimal, it's 0.042. And compounded monthly means N is 12. It's telling us that we want to know when they're the same at the end of the year, so this will be 12 times 1. And so we want this amount to be the same as if it was compounded continuously. So P is still 1,000, and we are trying to find the rate, and T is still 1. Okay, so when we look at this equation, because the variable is in the exponent, this is an exponential equation. And to solve those exponential equations, what we do is we isolate the exponential. So I can begin by dividing both sides by 1,000. And when I do that, the 1,000 just becomes 1. And let's go ahead and I think this simplifies pretty nicely to 1.0035, and then it'll be to the 12. And this will equal E to the R. And when we solve this exponential equation, we notice that the base is E, so this means I can align both sides. And which means on the right side, the R will come down, and natural log come down as a factor, and natural log of E is 1. So I've essentially found R. R is equal to natural log of 1.0035 to the 12. And when we plug this in our calculator, I'm getting about 0.0419. And so if we round this to, well, let's look at this a little further. So 0.0419266671. And if we maybe just, when we change this to a decimal and round it 3 decimal places, we'll end up with 4.193%. I didn't say how to round our problem in the rate, so I was just trying to look at the number and be like, what's a good rounding spot? So in some cases, just make sure to read the directions carefully to see how far to round. Another comment on this problem as well is sometimes your expression here may not simplify nicely. And in those cases, what I suggest doing is leaving this whole answer as it is. And then just continue to write this down here, write it down here, and then finally at the very end, plug in your natural log of what this expression is, so that your answer in the end will be in its most exact form possible. So this is the exact answer. This is still rounded, but by not rounding this part makes our answer here more like this one if we than if we rounded this. All right, so hope you found this problem helpful. It always is helpful just to read these a couple times. In this case, it was asking us to find that interest rate, which is the rate that's right here. All right, I'll see you in the next video.